Let's solve this problem. If you'd like, you can click the pause button and try to solve this problem yourself before you watch the video. ABCD is a parallelogram whose area is equal to 240 square units. The diagonals of a parallelogram divided into four triangles of equal area. The area of triangles ABO, CBO, CDO, and ADO is equal to 60 square units. Let's review the triangle DBM. By the menelaus theorem, if there is a triangle, in our case triangle DBM, and a transversal line crosses DB, MB, and DM at points O, T, and A, respectively, the product of these three ratios is equal to 1. If you're not familiar with this theorem, please check the link to my video in the description below. The ratio of DO over OB is equal to 1 because diagonals of a parallelogram bisect each other. The ratio of BT over TM is equal to 2 over 1. Therefore, the ratio of AM over AD is equal to 1 over 2, and AM is equal to MD. Let's review the triangle ADO. By the menelaus theorem, the product of these three ratios is equal to 1. The ratio of DM over MA is equal to 1, and the ratio of OB over DB is equal to 1 over 2 because diagonals of a parallelogram bisect each other. Therefore, the ratio of AT over TO is equal to 2. Let's review the triangles ABO and BTO. The ratio of the area of the triangle ABO over the area of the triangle BTO is equal to the ratio of the product of OB and OA over the product of OB and OT. Because if the angle of one triangle is equal to the corresponding angle of another triangle, then the areas of these triangles are related by the same ratio as the products of the sides enclosing equal angles. The area of the triangle ABO is equal to 60 square units, and since the ratio of AT over TO is equal to 2, the ratio of OA over OT is equal to 3 over 1. The area of the triangle BTO is equal to 20 square units. Let's review the triangle CBO. By the menelaus theorem, the product of these three ratios is equal to 1. The ratio of CN over NB is equal to 3 over 1, and the ratio of OA over AC is equal to 1 over 2. Therefore, the ratio of BQ over QO is equal to 2 over 3. The area of the triangle BPQ over the area of the triangle BTO is equal to the product of BP and BQ over BT and BO. The area of the triangle BTO is equal to 20 square units. The ratio of BP over BT is equal to 1 over 2. And since the ratio of BQ over QO is equal to 2 over 3, the ratio of BQ over BO is equal to 2 over 5. Therefore, the area of the triangle BPQ is equal to 4 square units. The area of the quadrilateral TPQO is equal to the area of the triangle BTO minus the area of the triangle BPQ, which is 16 square units. If you found this video helpful, please consider to subscribe to help my channel grow. Thank you.